Okay. Now the next question is, how will you determine activation energy graphically using Arrhenius equation? How will you determine activation energy graphically using activation energy? First of all, what is Arrhenius equation? Arrhenius equation is K is equal to A e raised to minus EA upon RT. This is Arrhenius equation. Now taking log on both sides for this equation, to this equation, we get taking logarithm of both sides of this equation, we obtain natural log K. Natural log K is equal to minus EA upon RT मायनस लॉग घेतल्यानंतर एक्सपोनेन्शियल फॉर्मचं कन्वर्जन कशामध्ये होईल मायनस ई ए अपॉन आर टी बाय टेकिंग लॉग ऑन बोथ साइड वी गेट नॅचरल लॉग के इज इक्वल टू मायनस ई ए अपॉन आर टी प्लस नॅचरल लॉग एला मी राईट हँड साईडला ए आणि ई आहे ना एला राईटला घेतलेला आहे आणि ई रेस टू मायनस ई ए आर टी त्याचा आधी लॉग घेतला सॉरी त्याचं कन्वर्जन आधी घेतलं ई रेस टू आहे ना त्यामुळे त्याचं काय होईल वन्स अगेन बघा इन के दॅट इज नॅचरल लॉग के इज इक्वल टू मायनस ई ए अपॉन आर टी बाय टेकिंग द एक्सपोनेन्शियल फॉर्म that is e raised to minus EART becomes minus EA upon RT plus कारण मल्टिप्लिकेशन आहे a into e आहे ना सो दॅट्स वाय प्लस नॅचरल लॉग ए सो therefore converting natural base to base 10 we write now conversion of natural base to base 10 we get the equation is log to the base 10 नॅचरल लॉगचं कन्वर्जन लॉग टू दी बेस 10 मध्ये केल्यानंतर नॅचरल लॉगच्या बेसला काय लिहायचं 10 लिहायचं आहे आणि इनचं कन्वर्जन लॉगमध्ये होतं सो दॅरफोर लॉग टू दी बेस 10 के इज इक्वल टू ई ए मायनस ई ए अपॉन 2.303 आर टी प्लस log to the base 10a. Here, this equation is of the type y is equal to mx plus c. Here, y is log to the base 10k, m is ea upon 2.303 r, and x is t, and c is log to the base 10a. Okay, so this equation is of the form of straight line. Y is equal to mx plus c indicates that straight line. So this equation is of the form of straight line. Y is equal to mx plus c. The Arrhenius equation graph of the Arrhenius equation, the graph of Arrhenius equation, that is log to the base 10k versus 1 upon t gives a straight line. When a graph of log to the base 10k is plotted with 1 upon t inverse of temperature gives a straight line, and the slope of the line is minus EA upon 2.303 r. The slope of this graph gives the value of minus EA. The slope gives negative value, that is EA upon 2.303 r, with its intercept being log to the base 10a. Intercept on y-axis indicates that log to the base 10a. From slope of the line, the activation energy can be determined. आणि या स्लोप वरून कुठली व्हॅल्यू डिटरमाइन करता येईल activation energy. Okay, so this is the determination, graphical representation of Arrhenius equation, graphical representation using Arrhenius equation. Okay, now next and very important derivation. How will you determine activation energy from rate constant at two different temperature? This is a very important derivation. काय क्वेश्चन आहे? How will you determine activation energy from rate constant at two different temperature? Or derive the relationship between activation energy and rate constant at two different temperature. Derive the relationship between activation energy and rate constant at two different temperature. First of all, what is Arrhenius equation? Arrhenius equation is k is equal to a e raised to minus ea upon rt. By taking log, this equation gives by taking log on both sides we get natural log k in k is equal to in a minus ea upon rt. Okay, so therefore converting natural base to base 10 we write आधीचं इक्वेशन पाहिलं तेच लिहितोय मी नॅचरल बेसचं कन्वर्जन लॉग टू दी बेस 10 मध्ये केल्यानंतर काय येईल लॉग टू दी बेस 10 के इज इक्वल टू लॉग टू दी बेस 10 ए मायनस ई ए अपॉन 2.303 आर टी. ओके, सो फ्रॉम टू डिफरंट टेम्परेचर T1 and T2 at two different temperature, or from two different temperature, that is T1 and T2, the first equation gives log to the base 10 K1 is equal to log to the base 10 A minus EA upon 2.303 R T1. This is equation number 1. And log to the base 10 K2. दोन डिफरंट टेम्परेचरला रेट कॉन्स्टंटची व्हॅल्यू चेंज होईल. फ्रॉम टू डिफरंट टेम्परेचर T1 and T2, the rate constant is given by log to the base 10 K1 is equal to log to the base 10 A minus EA upon 2.303 RT1. This is equation number 1. Second one, log to the base 10 K2 is equal to log to the base 10 A minus EA upon 2.303 RT2, where K1 and K2 are rate constants at temperature T1 and T2. Where K1 and K2 are rate constants at temperature T1 and T2. Okay, so therefore subtracting equation 1 from equation 2. आता 1 ला 2 मधून सबस्ट्रॅक्ट करा. काय येईल मग? log to the base 10 K2 minus log to the base 10 K1 is equal to minus EA upon 2.303 into 1 upon T2, minus minus plus होईल, so that's why plus EA upon 2.303 R 1 upon T1. So therefore log common काढल्यानंतर काय येईल? log to the base 10 K2 upon K1 is equal to EA upon 2.303 into bracket 1 upon T1 minus 1 upon T2. Okay, so therefore final equation, log to the base 10 K2 upon K1 is equal to EA upon 2.303 R into bracket T2 minus T1 divided by T1 and T2. Okay, so this is the rate constant at two different temperatures. Derive the relationship between rate constant at two different temperature, and the equation is log to the base 10 K2 upon K1 is equal to EA upon 2.303 R into bracket T2 minus T1 divided by T1 into T2. Okay, next question is, explain with the help of Arrhenius equation how does the rate of reaction changes with temperature and activation energy. How the rate of reaction changes? By changing the temperature and by changing the activation energy. So first, Arrhenius equation is K is equal to E. Arrhenius equation is K is equal to A e raised to minus EA upon RT. A राहिलेला आहे तिथे, इथे A राहिलेला आहे. So Arrhenius equation K is equal to A e raised to minus EA upon RT shows that as temperature increases, EA upon RT decreases. Temperature increase केल्यानंतर कुठली व्हॅल्यू डिक्रीज होते? Ratio of EA upon RT decreases and minus EA upon RT increases. The value of EA upon RT decreases and minus EA upon RT increases. This increases K and the rate of reaction. This increases K and the rate of reaction. Rate of reaction सुद्धा increase होतो आणि K सुद्धा increase होतो. As the energy of activation, आता activation energy चा इफेक्ट काय होतो बघा. As the energy of activation decreases, EA upon RT decreases and hence minus EA upon RT increases and the rate of reaction also increases. Temperature काय केल्यानंतर, टेम्परेचर इन्क्रीज केल्यानंतर EA upon RT डिक्रीज होतो, मायनस EA upon RT इन्क्रीज होतो आणि त्यामुळे K आणि रेट काय होतो? इन्क्रीज होतो. This increases K and rate of reaction with the increase in temperature. Okay, आणि activation energy increase केल्यानंतर as the energy of activation decreases, EA upon RT decreases and hence minus EA upon RT increases and rate of reaction also increases. Okay, so this is the effect of temperature and activation energy on the Arrhenius equation. Next question, explain graphically the effect of temperature on the rate of reaction. What is the effect of temperature on rate of reaction? इथे graphically सुद्धा दाखवलेला आहे. This is the graphically explanation of rate of reaction on the effect of temperature on rate of reaction. Explain graphically the effect of temperature on rate of reaction. Now, the average kinetic energy of molecule is proportional to temperature. The average kinetic energy of molecule is proportional to temperature. At a given temperature, the fraction of molecules with their kinetic energy at a given temperature the fraction of molecules with their kinetic energy equals to or greater than EA may leads to the product. परत एकदा बघा, ग्राफिकली आपल्याला एक्सप्लेन करायचं आहे. काय क्वेश्चन आहे? एक्सप्लेन ग्राफिकली द इफेक्ट ऑफ टेम्परेचर ऑन द रेट ऑफ रिॲक्शन. रेट ऑफ रिॲक्शनवरती टेम्परेचरचा इफेक्ट काय होतो? सो the average kinetic energy of molecule is directly proportional to temperature. Average kinetic energy is directly proportional to temperature. At a given temperature, the fraction of molecules with their kinetic energy equal to or greater than EA may leads to the product. जर given temperature ला kinetic energy equal किंवा greater असेल कोणापेक्षा? At a given temperature, the fraction of molecules with their kinetic energy, given temperature, fraction of molecules with their kinetic energy equal to or greater than EA, then the reaction leads to form product. Then the reaction produces product. Okay. So as the temperature increases, the fraction of molecules having energies, that is EA, as the temperature increases, the fraction of molecules having energies EA also increases. EA also increases as temperature increases. As the temperature increases, the fraction of molecules having energies EA also increases. The rate of reaction thus would increase. The rate of reaction increase. Okay. This is indicated by plotting a fraction of molecule. This is indicated by plotting a fraction of molecule with given kinetic energy versus kinetic energy for two different temperatures, that is T1 and T2. Here T2 is greater than T1. T2 is final temperature and T1 is initial temperature. So T2 is greater than T1. Final temperature is greater than initial temperature. Once again, third point, this is indicated by plotting a fraction of molecules with given kinetic energy versus kinetic energy for two different temperature T1 and T2. Okay. So this is the graphical representation for the effect of temperature on rate of reaction. Okay. So fifth point, the entire shaded area, this is entire shaded area, हा शेड केलेला एरिया आहे. the entire shaded area which represents a fraction of molecules with energy, the entire shaded area which represents a fraction of molecules with kinetic energy in which EA is larger at T2 than T1, since T2 is greater than T1. Okay. So this indicates that, this graphical representation indicates that, a fraction of molecules possessing energies, the fraction of molecules possessing energies larger than EA increases with temperature and rate of reaction also increases. This indicates that a fraction of molecules possessing energies greater than EA increases with temperature and rate of reaction also increases. Okay. So this is the explanation. Now what is catalyst? Give example. Catalyst means 11th standard ला शिकलेलो आपण catalyst. Catalyst is the substance which accelerate the chemical reaction and but does not take part in a chemical reaction. So definition of catalyst is a substance added to the reactant that increases the rate of reaction without itself being consumed in the reaction. Which does not consume in the reaction. Catalyst reaction मध्ये पार्टिसिपेट करत नाही, तो रिॲक्शनचा रेट इन्क्रीज करतो आणि रिॲक्शनमध्ये जो कंझ्युम होत नाही त्याला म्हणतात कॅटॅलिस्ट. अ कॅटॅलिस्ट इज अ सबस्टन्स ॲडेड टू द रिॲक्टंट दॅट इन्क्रीजेस द रेट ऑफ रिॲक्शन विदाउट इटसेल्फ बीइंग कंझ्युम इन द रिॲक्शन. फॉर एक्झाम्पल MnO2 इज द कॅटॅलिस्ट इन द रिॲक्शन. Decomposition of potassium chlorate twice of KClO3, potassium chlorate, KClO3, it is known as potassium chlorate. Potassium chlorate on decomposition in presence of catalyst MnO2, manganese dioxide, it produces potassium chloride and dioxygen. This method are useful for the preparation of dioxygen. पुढे P block element आहे, त्या P block element मध्ये सुद्धा, P block element means elements of group 16, 17 and 18, त्याच्यामध्ये सुद्धा ही रिॲक्शन रिपीट होणार आहे. So potassium chlorate on decomposition on heating in presence of manganese dioxide. टेम्परेचर किती यूज केले जाते याच्यामध्ये 420 केल्विन. When 2KClO3 on heating at about 420 Kelvin using MnO2 as a catalyst, it produces twice of KCl plus 3O2 gas. Okay.